let's use the criteria to select the correct graph. Now we'll be able to use a process of elimination to show why graph B is the correct answer. And we may not need all of these, but we will discuss how graph B confirms that all of these are true. So the first criteria they tell us is that the graph is continuous for all real numbers. That means the graph can be drawn without picking up your pen. So I look at my graphs. Graph A, using my pointer, I can draw without picking up my pencil. Graph B, same thing. Graph C, also. And graph D, I can draw it with one continuous motion. So criteria 1, or criteria A, is not enough to choose our correct answer B. Choice B, f prime of x is greater than 0 from negative infinity to negative 3 and from 1 to 3. That means the graph is rising on these intervals. So we're going to look for it to rise, negative infinity to negative 3 and 1 to 3. So look at choice A. Negative infinity means we're coming in this way on our graph. This graph is falling from negative infinity to negative 3. That means this cannot be our graph. Okay? Graph B is in fact rising from negative infinity to negative 3. And it's rising again. Look at the other part they told us. 1 to 3. So we go down here and we look. Here's 1. Here's 2, here's 3. So look, this is rising from 1 to 3. So graph B is okay, but we don't know about C yet. Well, except look, it's falling to negative 3. So we can eliminate choice C. And let's see about choice D. Choice D is actually rising from negative infinity to 3. But remember, the second place it was supposed to rise was from 1 to 3. And so I'm looking at this graph, and look, 1 is over here. It's actually rising from negative 1 to 3. So this is also a no. That means by the time we got to the second criteria, we have no on all of our graphs except graph B. Now let's look at the rest of the criteria and confirm that what they say is true for graph B. So the third one says f double prime, so make sure you're paying attention to the number of tick marks here, f double prime of x is less than 0 from negative infinity to negative 1 and 2 to infinity. And that means the graph is concave down from negative infinity to negative 1 and from 2 to infinity. So let's look at graph B. Concave down from negative infinity to negative 1. So here's negative infinity to negative 1. Yes, that's your bowl down. Now it turns at 1 and becomes bowl up, okay? But from negative infinity to 1, it's got the curvature down. So that part's right. And it says it's again from 2 to infinity. So here's, let's see, the scale is 2. So from here, and then the rest of the graph. So look, for the rest of the x values, they're in this bowl down situation. So that criteria about concavity is also true. The next one says f prime of x, f double prime of x is greater than 0 from negative 1 to 2. And that's when the second derivative is positive, greater than 0, that means it's concave up. So we need to look from negative 1 to 2. So here's negative 1, it's about right here because the scale is 2. And here's 2, and look, from there to there, Yep, we've got that bowl shape up. So that second derivative test shows true for this graph B. Letter F says f prime of negative 3 and f prime of 3 are 0. That means the slope of the tangent to f of x has a slope of 0. Okay, so that's a horizontal line. Remember, slope of 0 is a horizontal line. So when we look at these two values, f of negative 3 and 3, this is the first derivative. Here's negative 3, and my tangent line right there would be horizontal. Here's positive 3. My tangent line here would be horizontal. Now, it's also horizontal here, but just because it has another place where it's horizontal doesn't mean that we have to eliminate the graph. It just says that here and here that the tangent line is horizontal or the slope is 0. And the last one, the second derivative. The second derivative of x is 0 at these are points, negative 1, 3 and 2, 4. Well, these are inflection points because the second derivative tells you about concavity, and an inflection point is where the concavity is changing. So let's see if it's changing concavity at the point negative 1, 3 and 2, 4. So negative 1, 3 would be about right here. Look, because this is 2, so that's negative 1. And this is 1, 2, 3. Negative 1, 3. Look, it's changing from down to up. So yes, you have an inflection point right there at negative 1, 3. Then they said also at 2, 4. So here's 2, 4 right here. And again, it's changing from up to down at the point 2, 4. So we have confirmed that graph B is the correct answer and that each of these is true for graph B.